Let's talk a bit about alkalinity. Put simply, alkalinity is a measure of a stream's ability to resist changes in pH. In chemistry terms, alkalinity is the summation of the moles per liter of bicarbonate, 2 times the moles per liter of carbonate, and the moles per liter of hydroxide ions, minus the moles per liter of hydronium ions. To put it in simple terms, if there is little carbonate and bicarbonate in the water, then the alkalinity is likely really low, meaning the water is vulnerable to changes in pH. But let's take a step back and give an example to explain the importance of alkalinity. Let's say the Deer Creek Reservoir, which feeds into the Chesapeake Bay, is continuously impacted by acid rain or acid mine drainage from local mining activity. If Deer Creek has a high alkalinity, then there should be little to no change in its pH due to its ability to resist changes in pH. This is important because changes in pH are likely to have a negative effect on the health of a stream. For example, rainbow trout cannot reproduce in a stream with a pH under 6 and generally prefer water with greater than 20 milligrams per liter alkalinity. Many macro and microscopic organisms that trout feed off of are also influenced by pH, making alkalinity and pH also very important for aquatic food webs and the overall health of streams. Limestone, which is made of calcium carbonate, is likely to surround a stream with high alkalinity. When limestone dissolves, it releases carbonate and bicarbonate ions into the water, which, as we recall, are 2 important ions that contribute to alkalinity. Alkalinity is commonly expressed as calcium carbonate equivalents using a titration method, allowing the alkalinity measured in the water to be equated to an equivalent amount of calcium carbonate. Now let's see how we can test for alkalinity as calcium carbonate equivalents on a stream using an alkalinity titration test kit. Today we will be testing for alkalinity in terms of milligrams per liter as calcium carbonate. Before we actually try it out on a stream, let's take a quick look at the Hawk alkalinity test kit and the equipment inside. We have an Erlenmeyer flask, a graduated cylinder, these little tubes of sulfuric acid of varying concentrations, our digital titrator, and of course the Brome Cressel green indicator. The first thing to do on site is to rinse out our graduated cylinder and Erlenmeyer flask 3 times with the Creek sample, just to make sure we're not contaminating the test. And then what we're going to do is we're going to use the graduated cylinder to just measure our sample. And so we're going to fill this up to the 100 milliliter line, and we're just using the graduated cylinder to do this because it's more accurate. And then we're going to pour that into our Erlenmeyer flask so that we will have exactly 100 milliliters of Creek sample in our Erlenmeyer flask. Let's take a quick look at our digital titrator. So there are 3 main parts to the titrator. We have this little knob right here, which basically the purpose of this knob is to just zero this, like so. This is going to be right here. This is the plunger, which, as you can see, if you press this and hold it in and then drag this forward, it releases this plunger like so, which is going to help us to dispense the acid. So I'm going to put that back, and then this is actually going to dispense the acid in very, very, very tiny drops, and then this number, which you can read right here, will tell us the milligrams per liter of calcium carbonate alkalinity. So the first thing I'm going to do here is insert the cartridge of 1.6 normal sulfuric acid. Since I'm doing the 100 milliliter sample test, this is the one that I'm going to want to use. I'm just going to insert that in there, make sure that is in all the way. And then I'm going to put in this dispenser tube into the end of it. Now we want to be very careful with this here because we are dealing with acid, which is a dangerous chemical. We don't want that on our skin. We don't want that anywhere near our face. So what I'm going to do is I'm going to hold this upside down with this curved hook at the end here. That means that by holding it upside down like this, I'm making sure that none of it is going to spray up on me. Now I'm going to use the plunger. So I'll press in this button and push it until the end of the plunger reaches the top of the cartridge. Then I'll turn this knob until I see a drop of acid released from the thin hook dispenser tube. Now I simply re-zero it. So now our titrator is all set up. So the final thing to do would be to add in our indicator to a 100 milliliter sample and swirl it until we get an even green tint. Then we would perform a titration using the sulfuric acid, going until the solution turns and remains a reddish pink. So let's head over to the creek to see this in action. Here we are at Abers Creek with the Hawk Alkalinity Test Kit. The first thing we're going to do is rinse these out 3 times. Next, I collected 100 milliliters of sample. Pretty good, pretty good, pretty good. Alright, now I'm going to pour this into the Erlenmeyer flask. And now we have pretty accurately 100 milliliters. Alright, the next thing we're going to do is add in our indicator into our 100 milliliter sample. And now once we've got that all in there, we're just going to mix this around until this thing is an even green all the way through. I'm going to give that a second more there. Alright. Okay, so now what we're going to do is set up our digital titrator. So the first thing I'm going to do is, since I'm using 100 milliliter sample, I'm going to take this 1.6 normal sulfuric acid cartridge and insert it into the digital titrator. And then I'm going to put in this dispenser tube. Now I'm going to turn it so it's facing up this way, and you always want it facing up since it has this hook at the end. It's hooked downward. If you hold it down like this, it's not going to spray up in your face. So you really don't want that. So, being very careful here, let me try to push this plunger in so it's at the end. This is a fresh cartridge, so I'm going to have to be very careful here because it's probably going to squirt some acid out as I press this up. There we go. See, now we know that it's filled up with some acid, and just to make sure, as you can see there's a couple drops there, just to make sure, I'm going to turn this dial a little bit until I can see a drop coming out of the end. There, did you see that? So once we have it so that it's dripping out a little bit of acid, then we know at that point that we can finally zero it, and we'll be ready to start the actual test. Alright, now let's actually start the titration. Notice how I'm holding this stuff. I'm holding this all so I can operate this with one hand, while at the same time I have one hand holding the flask so I can shake this as I'm titrating this. So we're going to insert this actually into the solution, and now let's start releasing some of this in here. There we go, there's a little bit of pink. You see that? And so we're waiting until this turns pink and stays pink. But as I release this in here and I shake it around, oftentimes you see it slowly fades out. So we know once it stays pink, that's when we've reached our end point. Looks like we've got it. Aha, there we go. Nice. So let's see what the reading is on here. 44. An alkalinity of 44 milligrams per liter as calcium carbonate shows that the stream is healthy. This means that the stream has a strong resistance to pH change from acid rain. Stream water above 20 milligrams per liter as calcium carbonate makes a great home for fish like trout.